water, solid, and then water, liquid. Yeah. So how do we predict the sign? This one, delta H, is enthalpy change, and delta S is entropy change in a reaction. Okay. So when we say delta H, this means if the reaction absorbs heat or release heat. If reaction absorbs or releases heat. Yeah. So we take a look at if there is a bond being broken or formed. Breaking bonds, that means it requires energy. So delta H is greater than 0. So delta H greater than 0, that is endothermic. Delta H less than 0, this is exothermic. Okay, but it's not even given here, right, in the reaction that delta H is negative or exothermic. So from liquid to solid, from solid to liquid, the phase change. Yeah. So when a solid dissolves, the ions or molecules spread out, right? So what will happen to delta H here and delta S? For a while. So in solid, which one? Okay. So delta S is the entropy, right? So if when a solid dissolves, that means the ions and or molecules spread out in water. So more disorder. Therefore, delta S is greater than 0. You agree? So delta S greater than 0. This is positive. So therefore, it is related to enthalpy, delta H, because dissolving may absorb heat or release heat. Yeah, so in this case, we have water from solid to liquid. So it absorbs heat. In this case, it absorbs heat. So that means delta H is greater than 0. Yeah. Which is endothermic. Slightly endothermic. Okay. So what will happen here? Okay, delta S is greater than 0. Liquid is more disordered than solid. And then the melting requires heat. So it absorbs heat. So delta H is greater than 0. So the sign would be positive. Positive, and this one is also positive. Right. Yeah. If the particles are disordered, more disorder, then it's positive, the delta S, the entropy. If it is ordered, then it is negative. You got it? Okay, so this is the simplest rule for this. So if particles spread out, delta S is positive. For example, dissolving, melting, and forming gas. But if particles become more ordered, so delta S is negative or less than 0. So that is precipitation or freezing. Maybe you can go to the next page. I will write it down so you can go over this. Can you go to the next page? Okay, so you just take note that if particles spread out, then that means delta S is positive. And examples of this are dissolving, melting, or forming gas. If the particles become more ordered, or closer to each other, then delta S is negative. Examples would be precipitation, freezing. Okay, that is for delta S. And for delta H, if bonds break, then delta H is positive. This is endothermic process. If bonds form, delta H is negative. This is exothermic. Okay. So from the example, that is water, solid water to liquid. So that means dissolving, melting, to the particles spread out. So delta S there is positive. And melting requires heat. So delta H is also positive, greater than 0. But if the liquid freezes, so from liquid to solid, this is opposite to melting. So delta S is less than 0 because it becomes compact, unordered. So delta S is negative. Then it releases heat. Therefore, delta H is also less than 0. Right? Okay. Can you go to the next page? All right. Determine if the following reaction is spontaneous at 25 degrees Celsius. So the reaction is N2, nitrogen gas, plus oxygen gas. Okay. Then NO2 gas. Then we're given delta H here equals 68.0 kilojoules per mole. Then delta S is equal to negative 0.122 kilojoules per mole Kelvin. Okay. We have to find delta G. Delta G is Gibbs free, right? So to determine whether a reaction is spontaneous, we should always look at the sign of Gibbs free energy, delta G, which is denoted as delta G. So a reaction is spontaneous if delta G is less than 0. So let's solve for delta G. So what's the formula for delta G in terms of enthalpy and entropy? Okay, so change in enthalpy minus the temperature times the change in entropy. Okay, take note here that the temperature should be in Kelvin because the unit here for the entropy is in Kelvin. So we should convert this to Kelvin. 25 degrees plus 273. This is 298.15 Kelvin. Then we plug in everything. Okay, so delta G. Notice that delta H is positive. Delta S is negative. By just looking at this one without even computing, okay? Delta H is positive. Delta S is negative. So delta H is unfavorable. Delta S is unfavorable. So this can be non-spontaneous, but let's show it if it's really non-spontaneous. So delta H is 68.0 kilojoules per mole minus the temperature, which is 298.15 Kelvin, times negative 0.12 kilojoules per mole Kelvin. So delta G, sorry. Try to solve it. 298, it's positive, right? 298.15 times 0.12. So this is 68.0 plus 35.778, which is positive 103.778. Take note here, delta G is greater than 0. Yeah. So that means this one is non-spontaneous. Because the reaction will only be spontaneous if delta G is less than 0, a negative. All right. So therefore, this reaction is non-spontaneous. You got it? So let me break this down for you. Can you go to the next page so I can discuss more? Okay. So you would fully understand. So spontaneous, delta G is less than 0. This one is spontaneous. Okay. And then you use this formula to prove that one. Okay. Then how do we predict? There are cases. So the first case, okay, case 1. If delta H is negative and delta S is positive, okay, delta H here being negative is favorable. Then delta S positive is also favorable. Therefore, a reaction that has these values of enthalpy and entropy are always spontaneous, as delta G is always negative for spontaneous reactions. And then case 2, what if delta H is positive and delta S is negative? Okay, so delta H is positive, that means it's not favorable. Yeah, unfavorable. Let me say unfavorable. Then delta S is negative, unfavorable. Therefore, the reaction is never spontaneous. And then another case, can you go to the next page? What if both are negative? What if, yes, so what if both are negative? Let's say delta H is negative and delta S is negative. All right, so delta H negative, this is good, right? Favorable. Then delta S negative, unfavorable. So you take note of the temperature. If the temperature is low, then it's spontaneous. So spontaneous at low temperatures. You can do like this. At low temperature T, delta G is just equal to negative with a very small number. So negative or a small number. So that means the reaction is spontaneous. If the temperature is high, at high temperature, delta G would become a big number, positive. Then this is not spontaneous. Okay, that is case 3. How about when both are positive? Can you go to the next page? Yeah. What if both, okay, this is case 4. Delta H is positive and delta S is positive. Okay, so delta H positive, yes. So this is unfavorable, right, for positive. And delta S positive, this is favorable. Okay, the third case, spontaneous at low temperature, right? So in this case, spontaneous at high. So at high temperature, so you take a look at the high temperature. Delta G is positive. So this is, no, okay, high temperature, no. Okay, at high temperature, so you have delta H positive, and then you have high temperature, so that would become a big number. Okay, because delta G is delta H minus delta S, that would become temperature. If you have big number there, or high temperature, so that would become negative. So positive and negative, that would become negative, right, for delta G. So this one is spontaneous at high temperature. Then at low temperature, delta G, that would be that would give us a small number. Small number but still positive. So this is not spontaneous. So in the two cases, you take note of the temperature. So both negative, it's spontaneous at low temperature. Both positive, spontaneous at high temperature. Yeah. Can you go to the next page? Summarize that one. So delta H, delta S, spontaneous. So if this is negative, positive, negative, negative, positive, 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 negative. So this one always spontaneous. This one spontaneous at low temperature, spontaneous at high temperature. This is never spontaneous. All right. Okay, so let's take a look at the third problem you sent me. Can you please go to the next page? Determine if the following reaction is spontaneous at temperature 50 degrees Celsius, and then we're given this reactions, methane, 2O2, then carbon, and water. Okay, and delta H is negative 882 kilojoules per mole. Then delta S, negative 0.004 kilojoules. They're both negative, right? Yeah. So what is the condition for both negative? Yeah, spontaneous at low temperature. We don't know if 50 degrees is low or not. Is it? So let's convert this to Kelvin. 273 plus 50. 323.15 Kelvin. So let's solve the delta G. 882 minus 323.15 times negative 0.004. So this is negative 882 plus times 0.004. This is 1.292. So delta G here is negative 880.71 kilojoules per mole. It's negative, right? So delta G here is less than 0. Is the reaction spontaneous? Okay. So that means temperature 50 degrees Celsius is low temperature. Yeah, because we have delta H and delta S both negative, and the reaction is spontaneous at low temperature. Got it? So that's how to find which substance has the greatest entropy. So that is the main rule. Now we're given here 4. So the first one, we have CO2 solid, then H2O gas, then CCl, carbon tetrachloride liquid, and then what is this? CHCl3 liquid. All right. This is solid. So this one has the lowest entropy. Gas, this one is the highest. Then liquid, okay. We're only asked would have the greatest entropy. So the answer should be water vapor, gas. Yeah, so that would be H2O gas greater than CCl. Okay, you take a look at the table for the values because we have two liquids here. If you have values, so you can just because I don't know which one, CCl4 or CHCl3. So you can just interchange them later. But the highest here is the gas and the lowest is CO2. CO2 is carbon dioxide, and then carbon tetrachloride, it's not even in the table. Yeah. Okay, so that is the order. CH2. Okay, so that is the order for that. For number 5, from the following equations, select those that tend to be spontaneous. So which ones here are spontaneous? We have nitrogen gas and oxygen gas, then N2O5 plus heat, and then we have water solid plus heat. This is melting, so this is to liquid, then that is definitely spontaneous, right? Plus oxygen gas, 2NO gas, and delta H is positive. 180.6. Then number 4, we have C6H12O6, solid plus oxygen, gas, then carbon dioxide, gas, plus water, liquid. Delta H here is negative. And then for the last one, calcium chloride, solid, it shades into ions, aqueous, plus 2Cl minus plus heat. Okay. Okay. It doesn't matter. Everything is gas, right? So you're right. This one is spontaneous. Yeah. Well, we have NO bonds. Okay. So delta H here is positive. Okay, positive endothermic. Then delta S is okay. All right. So this is spontaneous. The next one, solid to liquid. This one is also spontaneous, right? And then for this one, gas, delta H is positive. Delta H is positive. Everything is gas. What will happen to, okay, delta H is positive. What will happen here? Delta S, the sign of delta S. Okay, it's from the table. Okay, delta S, it is positive if it has more disorder. It's negative if it's less disorder. So everything is gas, so it's more disorder. So that means delta S can also be positive. Yeah. So delta S here is positive. Then delta H is positive. Okay, what will happen? Positive, positive. And then that means spontaneous at low or high temperature. Okay. Well, we don't know the temperature for this. They have a table for the temperature. If delta H is positive, that means it needs heat. And delta S is positive, it's more disorder. So it's delta G would be 180 minus delta S is positive. What happened? At 10, not really like spontaneous. So if it's positive, so it's spontaneous, right? Right? Spontaneous at high temperature. Okay, this one is a combustion process because the products are CO2 and water, and then we have oxygen. The glucose reacts with oxygen, so this is glucose combustion. So that means, okay, combustion releases a lot of energy, and delta H here is negative. So that means delta S, okay, delta S would be, we have one solid, 1 mole of solid, and 6 moles of gas. So we will just check the number of moles here. So 1 mole of solid and 6 moles of gas. So most of the reactants are gases, right? And then we have CO2 in the product side. CO2, they are gas molecules, and water, liquid. So CO2 is gas. That means this is more disordered or disordered. And the liquid has water is liquid, so it has less entropy than gas. Yeah. So okay, if we're going to add them up for the delta S, so that means delta S, you were right, delta S is positive, increase in disorder. Therefore, delta G in this case also increases. Decreases. Because delta S is greater. Delta H is less than 0, negative, favorable. Delta S is positive, favorable. So delta G is less than 0. So that means this number 4 is spontaneous. Spontaneous under normal conditions. But how come in your choices you only have... Okay, number 1 is spontaneous. Number 2 for sure is spontaneous, and number 4. Alright, I'm just confused in this. The choices. Because you only have like a few in your choices. Yeah, that's why I have to review it again. Okay, number 2 is surely spontaneous, right? Because that is solid to liquid. Number 4, okay, I'm sure with this one. That is spontaneous. So 2 and 4. 1, they're all gases. Then we've already analyzed that. Okay, number 4. Let's take a look at number 5. So we have CaCl2. We dissolve CaCl2. Okay, let's just assume this is dissolved in water because it dissociates into into ions, calcium ions, because it says here aqueous. So that means it dissolves in water. We have water here. So, okay. So dissolving again, right? It's exothermic. It releases heat. Dissolving. Because this is one of the examples of spontaneous reaction. Dissolving. This releases heat. Therefore, this is exothermic. Therefore, delta H is less than 0. Is negative. And then entropy. Entropy here, our original reactant is calcium chloride, which is solid. And then we add water. So it becomes hydrated ions in solution. So that means it is more disorder. So delta S is greater than 0. It's positive. Delta H is negative. Delta S is positive. So that means this is also spontaneous. Okay, now everything is spontaneous. Maybe, okay, I don't, it's confusing the choices here. Okay, let's just encircle the ones that are sure. So number 2, that is surely spontaneous. Number 5 is surely spontaneous. So we're left with 1, 2, 3. It says 10 to be spontaneous. But we don't know. Number 3, we don't know if it is it has a high temperature. It's not given, right? There's not much information there, so this is number 3 is questionable. That's why I wrote here spontaneous at high temperature. Number 4, I'm supposed to be sure with this. Yeah, so delta H is negative. Okay, this is a bit messy for number 4. Why? Because the reactants, okay, we have solid and gas, and then the product we have gas and liquid. So we don't know which one transforms to gas or liquid, right? Yeah, so maybe this is not sure for number 4. But unless it's because I already explained to you this one, like, okay, if it's solid to gas, of course, more disorder, so entropy increases. But we have another reactant, oxygen, because this is combustion. Yeah, so we don't really know which one transforms to gas, transforms to liquid. So let's just say this is questionable. Number 3 and 4, we're sure with number 2 and number 5. How about number 1? Are we sure with number 1? Number 1, they have the same state, gas, and plus heat. What do you think of this? Okay, the bonds break, right? So what will happen to the enthalpy? But when bonds are formed, analyze this one, the number 1. So bond, if the bond breaks, it requires energy, right? Okay, let me write that down. Bond breaks require energy. Requires energy. So that means delta H is greater than 0. This is endothermic. When bonds form, releases energy. So that means delta H is less than 0. This is exo. Right? Okay. So exothermic examples of this: heat released, energy out, forming bonds, making bonds, combustion, the number 4. Freezing, condensation, neutralization. Then greater than, bond breaks, heat absorbed, breaking bonds, melting, boiling. Okay. So number 1 is spontaneous. Okay, let me check. Yeah, let's just answer that one.